find the inverse of a 3 by 3 matrix. It is a little intense. To be honest with you, it's a little intense. Don't worry about it. And don't worry about using paper. You're going to use a lot of paper right here. So just get ready for it. And just be ready, because here we go. Here we go. So the first thing we want to do is we want to find the inverse of this guy. And we want to verify it. Now, with a 3 by 3, it's different than a 2 by 2. You can still find the discriminant of a 3 by 3 pretty quickly and easily. But there is no then easy short way to find from the discriminant the inverse of a 3 by 3. There's only the long way. And I wish there was a short way, but there's not. So the only way to get this thing going is to begin. So what we're going to do is we're going to take this matrix right here, and we're going to rewrite it again. So we have 1, -2, -4, 2, -3, -6, -3, 6, 15. And I'm going to draw a line, the dotted line right down. And over here I'm going to put the identity matrix for a 3 by 3. Looks like that, okay? So now the process that we go through to get this to happen here, folks, the process that we go through to get this to happen is we're going to go through and do what's basically, we're going to do basically the Gauss-Jordan method and make this look like the identity matrix. So as we do all the stuff to the left side, things over here on the right side will start to change. And when we get all said and done, everything over here on the right will be our inverse matrix. Okay, let's get to it. So again, remember, this is row 1, row 2, row 3, okay? And the first thing I want to do is I want to get row 2 and row 3 to have zeros here at the beginning. So the very, very first thing I'll do is I'm going to take -2 times row 1, add that to row 2, and replace it with row 2. Then what I'm going to do is I'm going to take 3 times row 1, add it to row 3, and replace that with row 3. So I'm going to kind of, in a sense, do them simultaneously, kind of, sort of ish. So let's just do like the first one first. Okay, so row 1's not going to change. Row 1 is not going to change. Notice here, this is going to change row 2, and it's going to change row 3, but row 1 is not getting changed right now. 1, -2, -4, 1, 0, 0. Here we go. Take -2 times row 1. -2 times -2 is -2. Plus 2 is 0, because I'm adding it to row 2, and it's becoming my new row 2. -2 times -2 is 4, plus -3 is 1. That becomes my new row 2. -2 times -4 is 8, plus -6 is 2. -2 times 1 is -2, plus 0 is -2. -2 times 0 is 0, plus 1 is 1. -2 times 0 is 0, plus 0 is 0. Okay? Let's go ahead and take a look at row 3. To get row 3, I said I'm going to take 3 times row 1. So 3 times 1 is 3, plus row 3, which is 3 plus -3 is 0. Goes right there. 3 times -2 is -6. Plus 6 is 0. Goes right there. That's a good thing. 3 times -4 is -12. Plus 15 is 3. Goes right there. -3 times 1 is 3. Plus 0 is 3. 3 times 0 is 0. Plus 0 is 0. And 3 times 0 is 0, plus 1 is 1. So that's how I got. So far, all I did was do these two things right here. It brings me to here. I'm so close here on the bottom one, I just want that to be a 1. So what I would do then is I would take 1/3 of row 3 and replace that with row 3. So row 1 and row 2 are not going to change. So row 1 stays the same. Row 2 stays the same. Row 3 now, though, becomes 1/3 of 3 is 1. 1/3 of 3 is 1. 0, 1/3 of 1 is 1/3. Okay? Oh, got to keep remember I'm slow. Sorry. So all I did is I took 1/3 of row 3. Here's row 3. I took 1/3 of it, so divided everything by 3, and that's what I get. Row 1 and row 2 didn't change. Now what I'm going to do, so now the Jordan part of the Gauss-Jordan elimination says, now that we have the Gauss part, the Jordan part says I want to make this become a 0. The way I would do that is I would take -2 times row 1 and add it to row 2, and that's going to become my new row 2. Now I also want this to become a 0, so I'm going to take 4 times row 1, add it to row 1, that's going to become my new row 1. Okay? So let's see what I get. So the only one that doesn't change here, because look, we're going to change row 2 and we're going to change row 1. The only one that doesn't change is row 3. So I'm going to put row 3 in, 0, 0, 1, 1, 0, a third. Now to get row 2, I'm going to take -2 times row 1. Sorry, this should be -2 times row 3. I so apologize. This should be -2 times row 3. -2 times row 3, add it to row 2. So -2 times row 3. Remember, this is row 3, row 2, row 1. -2 times row 3. -2 times 0 is 0, plus 0 is 0. -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2, plus 2 is 0. -2 times 1 is -2, plus -2 is -4. -2 times 0 is 0, plus 1 is 1. -2 times a third is -2 thirds, plus 0 is -2 thirds. So all I did is I took -2 times row 3, added it to row 2, and replaced row 2 with it. Now I'm going to take 4 times row 3 and add it to row 1, and that's going to become my new row 1. So I'm going to take 4 times row 3, add it to row 1, and it's going to become my new row 1. So 4 times 0 is 0, plus 1 is 1. 4 times 0 is 0, minus 2 is -2. 4 times 1 is 4, plus -4 is 0. 4 times 1 is 4, 4 plus 1 is 5. 4 times 0 is 0, plus 0 is 0. 4 times a third is 4 thirds, plus 0 is 4 thirds. Okay? So I'm really close. The last thing I need to do is I need to get that to be a 0. So I need to multiply row 2. So I'm going to take 2 times row 2, add it to row 1. That's going to become my new row 1. Okay? Here we go. So row 3 is not changing. Row 2 is not changing. We can see that because this can become row 1. Row 1 is going to change. I got to take 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2. 2 plus -2 is 0. 2 times 0 is 0, plus 0 is 0. 2 times -4 is -8. -8 plus 5, -3. 2 times 1 is 2, plus 0 is 2. 2 times -2 thirds is a -4 thirds, plus 4 thirds is 0. Woohoo! Okay, notice how this now is the identity matrix, which means this over here is the inverse matrix. So I would say that the inverse matrix is -3, 2, 0, -4, 1, -2 thirds, 1, 0, 1 third. Now we need to verify it. So to verify it, what we're going to do is we're going to take our original matrix, clear back up here at the top. So we're going to take our original matrix. I'm going to come right here, and that's 1, -2, -4, 2, -3, -6, -3, 6, 15. We're going to multiply it by our inverse, or what we're claiming to be our inverse, which is right here at the bottom. -3, 2, 0. -4, 1, -2 thirds, 1, 0, 1 third. Okay? All right. So this is a 3 by 3. This is a 3 by 3. We can multiply them together. This is the new resulting matrix going to be a 3 by 3. So I'm going to put it right down here. Remember, if they truly are inverses of one another, we should get out the identity matrix right down here. So to find row 1, column 1, I have to take row 1 times column 1. So I take 1 times -3, negative 3, negative 2 times negative 4, 8, negative 4 times 1, negative 4, negative 3 plus 8 is 5, plus negative 4 is 1. So that 1 goes right there. Whew, we're running out of lead here. That's kind of crazy. I don't even know how to, oh, I think I can go like this. Oh, yeah. Here we go. So now we're going to go ahead and we're going to find row 1, column 2. So to find row 1, column 2, take 1 times 2, which is 2. Negative 2 times 1, negative 2. Negative 4 times 0, 0. That equals 0. Now to find row 1, column 3. Okay, to find row 1, column 3, I'm going to take row 1 times column 3. 1 times 0, 0. Negative 2 times negative 2/3, say positive 4/3. And negative 4 times 1/3 is a negative 4/3. It's going to be 0. Well, that's a good start. That's a good start. Here we go. To find a row 2, column 1. I have to take row 2 times column 1. 2 times negative 3, negative 6. Negative 3 times negative 4, 12. Negative 6 times 1, negative 6. It's going to equal 0. That's a good start there too. Now let's go ahead and take a look at row 2, column 2. So I get 2 times 2, that's 4. Negative 3 times 1, negative 3. Negative 6 times 0, 0, that's 1. Woo! Loving it. Loving it. Row 2, column 3. Here we go. Negative 3 times 0 is 0. 6 times negative 2/3. It's going to be negative 4. Is that right? Yeah. 6 times negative 2/3, negative 4. 15 times 1/3 is 5. Uh-oh. That's a problem. That's a problem. What happened there, folks? What happened? Oh. Yeah. It's row 2. Maybe I went messed up here. 2 times 0. Oh. Here we go. Maybe I think I went down. I think I went down instead of going to stay in row 2. My bad, my bad. So I should get 0. Negative 3 times negative 2/3 should be negative 2. So sorry. Negative 6 times 1/3. Oh, negative 3 times negative 2/3 should be a positive 2. Negative 6 times 1/3 should be negative 2. I kind of skipped down on my left. Sorry, I apologize. Instead of coming right across to row 2, column 3. So that's going to give us 0 plus 2 minus 2 is 0, which is what we wanted. Glad thing that worked out. Whoa, that was close. Row 3, column 1. Negative 3 times negative 3, it's 9. 6 times negative 4, negative 24. 15 times 1, 15. 9 minus 24, negative 15 plus 15, 0. Oh, baby. Oh, baby. Row 3, column 2. So negative 3 times 2, negative 6. 6 times 1, 6. And then 15 times 0, 0. That's going to equal 0. Dang. Row 3, column 3. Here we go. It's the big one. Negative 3 times 0, 0. 6 times negative 2/3. It's going to be negative 4. 15 times 1/3. 5, negative 4 plus 5, 1. And we come up with the identity matrix. They are truly inverses of one another. We found it. Woo woo. So this is the one we found right here. And it is the inverse to our original. All right. Whoo! One more video after this, and that'll be all of 6-3, folks. Good luck to you. Stay organized. It's kind of rough. Bye.